The life of a professor sounds really stressful. Knowing what you know now, would you still go into academia?
Do I have any regrets? No. This is the best job for me. I get to work on really cool stuff. I get to talk to smart people all day, every day. Some people want their job to like shut off when they go home. I do need like hours of like an hour here, an hour there of like time when I'm not thinking about my job, but I'm like okay with taking work home because I really love what I do. I love interacting with students. I like thinking about new ideas. I like having lunch with interesting colleagues. I like being my own boss. I don't like getting grants and papers rejected, but no one likes that. It happens that like 8 out of 10 grants I submit now, I'm a little bit better. I'm better at writing grants now than I was 4 years ago, but they still get rejected pretty often. There was a week in February where I had 3 rejections all in a row. I think 2 were even on the same day. So it does still happen, but my hit rate, my accuracy is better now than it was like when I recorded that video. But that's to be expected. I think a lot of it is choosing your opportunities more intelligently, and getting a better feel for like what a good grant proposal actually looks like. So no regrets. At the same time, though, there are things about my job that do get tiresome and that I want to do less of as time goes on. One of them is dealing with referee reports from journals and grant reviewers. So if I can like have maybe more targeted grant opportunities with stuff working on projects that I really want to do with students who are really motivated to do it, and not just like apply for every single opportunity possible, I'll probably be happier in the long run. One thing I like to do to kind of like keep this job fresh is to take on new like responsibilities and then maybe do other things less. For example, this class, I don't get paid for it, but I really enjoy doing it, right? Like there are people who are not doing a Revell College 1 unit seminar, and most of my colleagues are not doing this, but this is the kind of interaction that I really get derive a lot of energy from. I think it's important to talk about things other than equations and chemical balances and engineering-y topics and chemistry topics. So that's why I'm doing this. So this is the kind of thing that like keeps the job fresh, and often, and I'm not blowing smoke here. This is actually this hour from 1 to 2 p.m. on Tuesday in the spring quarter is like the most fun that I'll have today. So there are always ways to keep the job fresh. So no regrets.
Professors spend a lot of time writing grants and doing administration. Do you ever want to go into the lab and do experiments on the bench?
There are times when I have that fleeting idea, but this is actually related to your previous question, is how do I keep things fresh? So after high school, I was in school for 11 years before I could get this job. So 4 years of undergrad, 5 years of PhD school, and 2 years of postdoc. So 11 years after high school. For 9 of those years, I was in the lab every single day, including most Saturdays and Sundays, starting in 2003, the summer of 2003, when I first joined my first lab as a summer after my sophomore year as an undergrad. And 9 years straight, plus another maybe year where I was in the lab a lot between 2012 and 2013, helping students like start out, like grad students and undergrads who are in my lab. So being in the lab is something that I kind of spent enough time doing it, and that I don't feel like I feel like I can get the things that I used to get out of working in the lab, like myself, in other ways. For example, cooking and home repair tasks and things that involve a trip to like a Home Depot. And a lot of the day-to-day work in like engineering, like I still really enjoy like, working on a vacuum pump and like setting up reactions and like 3D printing something, even though, well, 3D printing wasn't the thing when I was in school. It started to become a thing at the end of my grad school. But anyway, there's like the working with your hands part, and there's the discovery part. I can do the working with my hands thing at home without like messing up my students' experiments. And also, I don't know where anything is in the lab anymore. Like, if I need a Sharpie, I don't even know where to look. If I need some acetone, I don't know where they keep that. So it's probably not even a good idea for me to be in the lab, honestly, to be from a safety standpoint, and then from an opportunity. So there's that part. There's the working with my hands part. The other part is like the discovery aspect. So the way it is now, I have 10 grad students and 2 postdocs, and something like 5 undergrads work in the lab. And they bring me data like a few times a week. And it's data that took them like the last 4 weeks to collect, because we meet individually every 4 weeks, and then every other 4 weeks that are staggered, we have subgroup meetings. So I'll see their data every 2 weeks, and I get all of the benefit from like seeing their data without actually having done it myself. And so there's that. And then the third reason is the opportunity cost. So in order to raise all the money that it takes to run the lab, it's like it ends up being in the few $100s per hour in order to pay everybody's salaries and to pay for all of their equipment and stuff. So I often feel like when I'm in the lab, and sometimes like I've been like tempted to go in there, but then I think about the opportunity cost and the fact that that every second that I'm doing something in there is like a second that I'm not like contributing to putting food on the table, so to speak, for my research group. So yeah, for those reasons, I do think about going in the lab, and then I'm like, it's probably better that I don't. But research is a lot of things. It's not just lab work. So research is, so there are some parts of the teaching, research, and service where you get to read in a new field, and that's research. You get to talk to people in other fields because you want to learn from them, because you want to like do a project at the interface of your field and their field. And that's really fun. So that's research too, but it's not in the lab. And that's the kind of thing that I do.
Where does a public university get its money, and how is it distributed?
So we have 4 major sources of funding. Let me make sure I can get all these straight. I'll say them and then I'll describe them. The first is tuition. The second is state funding. So funding that literally comes from the budget that they pass in Sacramento from California taxpayers. The third is indirect costs from grants. And that's like overhead that is charged on each of the grants. The fourth category is philanthropy. And so when you have a new, like the Jacobs Medical Center, it's because Irwin and Joan Jacobs gave money to the university to endow that medical building. Yeah, so state funding and tuition, as a general rule, does not get applied toward research. It does in some overlapping cases. For example, the TA budget, the budget for teaching assistants, is paid by state funding and tuition. My salary for 9 months of the year is paid by state funding and tuition. My salary in the summer is paid by grants. If I don't get grants, I don't get paid in the summer. Now they give my 9-month salary and divide it by 12 months, so I actually get a paycheck in July, August, and September, but technically I don't get paid in those months unless I get grants, and then I can take some of that grant money and apply it toward my summer salary. So when I'm doing research during the academic year and I'm mentoring students during the academic year on their research topics, that money is paid for by the state and by tuition. When you talk to your TAs, when you go to TA office hours or TA sections, their salary on the quarters in which they're TAs are paid by state and by state funding and tuition. So, but in terms of research supplies, zero of the money is paid by state and tuition. In terms of research facilities, some of it is, but it's hard to differentiate what came from grant overhead versus what came from tuition versus what came from state funding. Most public institutions, their total operating budgets are actually a very small fraction state funded. Some great examples, not the University of California, but Colorado Boulder, University of Washington, and countless others, they're like 5% of their total operating budget actually comes from the state. Even though there's, state schools, they actually operate in almost every way like a public university. And the same thing to a lesser extent is true with UCSD. So I actually don't know what the number is off the top of my head in the UC system, what percentage of our total operating budget is coming from state funds, as opposed to tuition and grant overhead and philanthropy, but it's much less than 50%. It's probably less than 15%, actually.
How much money does it cost to hire a graduate student, and how does this investment affect whom you hire?
As you mentioned, it costs a lot of money to have a grad student in the lab. And these numbers, the number that is pretty typical is like 75,000. And the reason it's 75,000 is because it has a lot of different parts. The main parts are tuition, or I'm sorry, we'll start with the take-home pay, because grad students get paid generally. So they get some stipend, which is in the 25K range. They get benefits, which are like health insurance and health insurance, dental, stuff like that, which is an additional few thousand. Then there is tuition remission, which is like an award that is paid to the student in the form of not having to pay tuition. So it goes from the grant directly to the university so that the student gets the degree credit without having to pay out of pocket for it. And that's another Depending on the school, it's going to be like 15 to 25K, depending on whether they're in state or out of state. Then you have overhead on the stipend and the benefits, which is going to be another like 15K ish. Then that will bring you into the 70-ish K realm. Then you have the, and then that's just to pay for the student without having done any research. But then they're actually doing research, so they have to, they need equipment and consumables, and then overhead gets charged by the university. So all of these expenses trigger more overhead, and so every time they use the clean room or a microscopy facility, or they order some petri dishes or gloves or pipette tips or chemicals or solvents, all of that stuff gets charged overhead as well, indirect costs. And that goes into everything that state funding and tuition goes into. It goes into this like pool of university expenses. And then when you add up all that stuff, it ends up being like 100K per student year. So the 75K is really just like the person, and then the extra 25K is all the stuff that they need. I should say, just out of, for complete bean counting purposes, overhead is not charged on equipment because the university gets to keep it, and and it depreciates when it's here. So for some reason, the accounting, they don't charge overhead on equipment, and they don't charge overhead on tuition remission, which would be kind of ridiculous because the tuition remission is already overhead. Like, it's already the pot of money that goes directly into the university's coffers. The overhead rate is started at 55% at UCSD when I started. And then it's crept up a little bit. It's like 57-ish now. And remember, that's not of the total, that's of direct costs. So for every 100K spent, you need another 57K to cover indirect costs, overhead. The second part of the question is, do I factor this huge amount of money into recruiting decisions? And the answer is 1,000% yes. And there is the person, and we're talking about grad students and postdocs here. We're not talking about undergraduates. For graduate students and postdocs, you need a lot of curiosity, you need a lot of commitment, and you need to be a good team player. And those are the things that a team player, and need to be trainable. So curiosity, commitment, teamwork, and willingness to step outside your comfort zone and learn something to a depth that nobody else has learned that particular thing before, because that's what a PhD is like. The PhD degree is it's like a in a martial arts analogy, it's like a black belt in creating knowledge. And it's also like the PhD thesis itself is like a dent in the unknown. It's like taking a bite out of the unknown. So that's kind of how I view the PhD. And then actually, when a postdoc is done with their time in the lab, that's sort of the expectation for them too. They don't get a certificate. Sometimes they do, not generally, but that's like the expectation. So it matters a lot. Like if a student is not like really intensely curious about science or how things work or making the world a better place through technology, it's not going to work out. But probably those people wouldn't be drawn to apply anyway. But there's going to be a a gradient of where those like four criteria lie on the the scale.
How do you feel about productivity hacks like batching similar tasks?
There was a time when I scheduled all of my individual meetings with grad students on Thursdays. And I just scheduled them back to back to back, lunch back to back to back to back. And then I didn't schedule any other meetings on Thursdays, and I had like the rest of the week to do other things. It turns out that that didn't work so well. So my the problem was there were a few problems. One is that I had to prepare for these meetings, and I had to like read the students' work before showing up to the meeting. And it was too difficult to do the day before. Sometimes a student would send me something in the morning for a meeting in the afternoon, thinking that was enough time for me to read it. But then I was in meetings the entire time up until that meeting, so there was no time to read it. The other issue is that I got really tired of meetings by the end of the day, and I felt like I was not giving my best attention to the students at the end of the day, and so as a result, I still batch, but not to that extreme level. I use the afternoons for meetings, so like 1 to 4 are my prime like meeting times, and I schedule all of my lab-related meetings between 1 and 4 on weekdays. So I have the mornings to make sure that I get done whatever administrative tasks need to be done. Most of my creative work, where I need like hours at a time, is done like when my 2-year-old is sleeping on the weekends, and sometimes there will be tracts of time in the mornings where I don't have any like pressing like urgent administrative task that I can work on. So that's kind of how it's shaken out now. It works a lot better for me now than it used to. Fridays, I try to keep totally unscheduled so that if I want to work from home, I can. Or if my wife gets the day off or something, we can like do something, take like a rest day where the kid is in daycare. But that doesn't happen that often. So that's like, that's how I try to schedule my week.
Are undergraduate researchers a negative cost to the lab since they pay tuition to get training?
Yes, that is true. The only caveat is that for the first several months of an undergraduate being in the lab, there are a lot of like startup costs. So it takes time of the grad students and postdocs to train new undergraduates to do the work. After they're trained, they are totally like have a negative cost to the lab. So that is definitely a thing. But it's convincing the grad student mentor and the PI that the undergrad is committed and curious enough about that particular research topic to spend the few months or maybe half a year required to like bring them up to speed so that they are don't require lots and lots of attention.
What happens if a PI can't get a grant? Does the lab go bankrupt?
If a lab fails to get a grant, there is some kind of like bridge funding sometimes where a university might have like maybe $50K to give to a lab for like a year so that they can get back on their feet. But that's not going to get you very far. And if this happens to a tenured professor, where a tenured professor loses all of their funding, then the school can take but they're teaching and they're doing all their committee responsibilities. The school can take their lab away. They can take their lab space, but they can't fire that person for not getting a grant. But they're also not going to be eligible for like professional advancement, like accelerated promotions, or even like merit advancements if you don't publish. So at UCSD, at the assistant professor and associate professor levels, you're reviewed every 2 years. And then at the full professor level, you are reviewed every 3 years. And in my department, you need four original research papers per year to get a normal merit advancement. And if you don't have any money, then it's really hard to get original research papers unless you do all of the work yourself. And you know how professors feel about spending time in the lab. So that's really not likely to happen. And in order to like get even a merit advancement, you would have to do such an amazing job teaching and take like extra responsibilities teaching that they'll give you the promotion anyway. But they don't have to give it to you. So that's kind of how that works. A lab can go out of business, but if the person's tenured, they can't be fired unless they do something like illegal or really unethical.
What happens to the students and postdocs in a lab that loses its funding?
In labs that lose their funding, the postdocs and the grad students usually find a new lab. But sometimes it happens where ideally the PI knows which grants are going to run out and which ones are not going to be renewable, and hopefully those grants have a timeline that's kind of commensurate with the time that the student or postdoc is going to leave the lab naturally, either by graduation or by finding a job, in the case of a postdoc. So it's a very tragic occurrence when it does happen, where the funding just completely runs out and there are still grad students who are only 2 years in, say, but then they usually have to find another advisor or leave with their masters. But it's important, when you're searching for PhD positions, that you find labs that are, decently well funded, where this isn't probably going to be an issue. I'm not aware really of any time in my department at UCSD, or any department that I'm familiar with, where the PI just completely ran out of money and could not pay the student. If the student is close to the end of their PhD anyway, then they might just do a TA-ship until they can graduate, because the TA-ship will pay for their expenses. They could TA the entire time, in which case it wouldn't take the PI any money to pay for them, except for their equipment. Except if you're a TA for 20 hours a week, it's really going to eat into the time. It's going to obliterate the time for research.